in this beautiful subject of thermodynamics. I myself Shivam Dixit welcoming you all in this beautiful series for GATE 2027. Enemy is God. Congratulations, Saks is back. Thank you. Hi Ars, hi Sujata, how are you? So today we are going to talk about the last topic of basic thermodynamics, that is thermodynamic relations. So today we are going to talk about thermodynamic relations, right? Just give me a minute. Yeah, it is fine. Just a minute. Okay. So now we are going to start our discussion on thermodynamic relation. So first, the most important part, that this topic is not that much important. I would like to say clearly, right? I would like to say clearly, because up to now in last 15 years, if you see, hardly 3 problems were asked from this particular topic. Out of that also 1 to 2 problems was very obvious, even you know that, right? Only derivation is done here. For example, Cp minus Cv is equal to R, that is Mayer's equation for ideal gas, that you know. But derivation is done in this particular chapter, right? So in this chapter only derivations are there, only and only derivations are there, nothing else. So we are going to discuss all those things in detail. Okay, so the first thing that I have told you, that this topic is not that much important. The reason is, as per as exam point of view, as per as GATE is concerned, right, rarely few questions are coming, and here also only few things are important through which the question can be framed. I will let you know. So the first of all, I would like to share here why this chapter, right? What is need of this particular chapter? So even in classical thermodynamics, very good evening, life, love, right? So very good evening. So if you talk about this particular chapter, so in this chapter, like what is the need of this particular chapter? So in the subject thermodynamics, we try to establish the relation between various properties, right? Where among various properties, various different type of relations we develop. For example, dq is equal to du plus dw is also kind of relation. S2 minus S1 is equal to CPln T2 by T1 minus Rln P2 by P1, that is also a kind of relation, correct na? For let's say another equation like W max is equal to U1 minus U2 minus T0 S1 minus S2 is also kind of relation. So in various parameters we have already developed number of relations. Now, whatever relations we have developed up to now, that is on the basis of laws, that on the basis of science, laws, right? But even we can develop some of the relation with the help of mathematics, right? Here we can develop some of the relation on the basis of mathematics. So the first thing that we are going to talk about, that we have already discussed, right? We have already discussed one very simple concept, that is principle of exact differential. We have already discussed the principle of exact differential. Principle of exact differential we have discussed. On the basis of principle of exact differential, Maxwell have, right? Maxwell actually given some of the relations, some of the equations basically, and these equations are sometime it is helpful, but okay, for proving something it is okay, fine, but up to now I have not seen any numerical problem on this. Only few questions I have seen in PSUs and even ESC prelims exam where they used to ask that some 4 options are given and they will ask that which one is not a Maxwell's relation, right? This kind of question could be asked. Achha, one very important fact I would like to share here, that earlier this chapter were very important for ESC conventional prospective. This chapter was very important for ESC conventional prospective, but now this chapter is removed from ESC, right? This chapter is basically removed from ESC, right? Hello ghost, gaming ghost, What happened? Gaming ghost. So what I'm trying to say, that earlier this chapter was very important as ESC conventional is concerned, but this topic was removed from ESC, right? Few year back it is actually removed. So now the importance of this particular chapter is very much reduced because it is not asked in a gate. Like few things are there which can be asked, and not much asked in ESC prelims also. Not in ESC prelims also it is removed. Yeah, ESC it is removed. So the importance is basically less, I would like to share. Okay, now few only, right? Yeah, this is the last lecture, Ghost Gaming. This is the last lecture, and this will also hardly take half an hour. That's it, don't worry about it, right? It will take hardly half an hour, and in half an hour I will tell you some basic equations that you need to remember. That's it, right? So please start to understand. So Maxwell's relations. So to remember this equation, there are four equations which are Maxwell equation. So I would like to share here what are those basically equations, right? What are those basically equations? So for this, if you want to know what is that, like if you want to remember these equation, then you will surely forget it. You will surely forget it. So I will share you one trick, right? What is the trick? The trick is very simple, right? Shivam sir is very talented person. What you have to remember? You have to only remember Shivam sir is a very talented person. Shivam sir is a very talented person. Correct? Shivam sir is a very talented person. This you have to remember. Now, so now what you need to do? So just draw one rectangle. Just draw one rectangle and write Shivam sir is very talented person. Shivam sir is a very talented person, right? Now start from any one point, right? Let's say I'm starting from here, right? I'm starting from here. I'm writing like this. This is like three properties should be connected. Then whatever remaining from the here you have to start and write in a go in a reverse direction, something like this. Now, if arrow is whatever arrow is like this, means downward direction, something like, if arrows are like this, either this one or this one, then it is considered as negative. If arrow is upward, then it is considered as positive. So first I will write this one, right? Dou P by dou S at constant volume. So I can write here dou P by dou S at constant volume is equal to dou T by dou V at constant entropy. Dou T by dou V at constant entropy. Right. Now here this is downward, so this value will become negative. So this is the first Maxwell relation. This is the first Maxwell relation, right? Similar way you can find out, wait, just wait, just give me 1 minute, please. Just give me 1 minute. Please write another equations also. right? Okay, wait, SVTP, right? Now the next equation that you need to write, again you draw a small rectangle and start with a Shivam sir, very talented person, right? Now earlier we started from P, now I started from S, so it is something like this, and then it is something like this, right? It is something like this, and then it is something like this. Okay, now if I write here this dou S by dou V at constant temperature, dou S by dou V at constant temperature, now it is downward, so it will be negative, is equal to minus dou P by dou T at constant volume. So this minus will be cancelled out. Derivation I am not doing, right? Derivation we have already did in the class. Derivation part we have already did in the class. So here only I am telling you the shortcut to remember the formula. Right now the next one is Shivam sir, very talented person. Right, Shivam sir, very talented person. So let's start from V, right? Let's start from V. So it will be something like this, then it will be something like this. Okay. All right. Then I can say that this value, this is negative basically. So dou S by dou P at 1 minute, dou S by dou P at constant temperature. Thank you. उल्लू भैया थोड़ा पानी दे देना. Right, so dou S by dou P at constant temperature, that is negative because it is going downward, is equal to dou V by dou T at constant pressure. This is upward, so positive, right? Then let's talk about Shivam sir, very talented person. Shivam sir, very talented person. Now if I start from T, then it will come something like this. So I can say that dou T by dou P at constant entropy is equal to dou V by dou S at constant pressure. Thank you. Okay, so these are the 4 Maxwell's relations, right? These are the 4 Maxwell's relation. ये दवा खाना पूरा सर दर्द कर रहा बहुत तेज. Sorry. Okay. Now, so these are the Maxwell relation. Now coming to the TDS equation, right? TDS equation. So there are 2 TDS equations. So even I don't remember that equation. So I also need to check because I can derive it here, right? I can derive it very easily, but derivation will take some time, right? So better to give you the directly values, right? So the TDS equation. One more equation I would like to share here. One more very important equation is there, that is called as cyclic relation. Cyclic relation, right? What is cyclic relation? You can remember like this: P V T T means dou P by dou V at constant temperature. So dou P by dou V at constant temperature into dou V by dou T at constant pressure into dou T by dou P at constant volume is equal to -1. So I am only telling you, no, nothing happened, just headache, right? Just headache. Nothing happened, bhai. Just headache. So if you look at, my dear student friends, so what exactly you need to remember, right? What exactly you need to remember? The first, like Maxwell's relation, right? First you need to remember Maxwell relation. The another point is cyclic relation. That is a cyclic relation, right? Then coming to TDS equation, what is TDS equation? TDS equals to, there are two TDS equation. One is TDS is equal to CV dt plus, I think, T into, what is there? CV dt into T into dou P by dou T. T into dou P by dou T at constant volume into dV, right? This is basically the first equation. First TDS equation, same, no, right? Yeah, first TDS equation. Now if I write the another TDS equation, then it will come TDS is equal to CP dt minus T into dou V by dou T at constant pressure into dP. That is equation number 2, right? That is equation number 2. Shashank, I remember you. You are very talented guy. Now if I equate these two equations, right? If I equate this equation, like left hand side of these equations are same. So from equation number 1 and 2, from equation number 1 and 2, if you equate and take Cp dt one side, then you will get Cp minus Cv is equal to what you will get? Directly equation I am telling you. The equation which you have to Cp minus Cv is equal to minus T dou P by dou V, minus T dou P by dou V at constant temperature into dou V by dou T at constant pressure ka whole square. So this you will get exactly, like when you equate these two and do some manipulation, do some changes, then you will get this particular equation, right? Now in this particular equation, you know that this T is absolute temperature, so this is always positive. This is a square term, this is also always positive, and this is basically negative. This is always negative. So now you can see that this negative will become positive, means Cp minus Cv is equal to positive. It means that Cp is greater than Cv. Gamma is equal to Cp by Cv. So gamma value is greater than 1. Gamma value is greater than 1, right? Gamma value is greater than 1, right? Okay, so Cp minus Cv हो गया. Now if I reduce this equation for ideal gas, so for ideal gas, if I reduce this equation for ideal gas, then you will get Cp minus Cv is equal to R. Basically for any gas, this is the equation. This equation is for any gas. This equation is basically for any gas. This equation is only for this particular equation is for any gas, and this is only and only for ideal gas. This one is basically for ideal gas. Clear hai? This equation for any gas, this is for ideal gas. Same equation, right? Means for ideal gas, this part of the equation will reduce to the R. Okay. Now I'll tell you the energy. Okay, energy equation also I'll give you. Two energy equations are there. Energy equation. The first energy equation is du is equal to, per kg I am writing, du is equal to Cv dt plus, let me write, let me see here. Where is that? Just du value is Cv dt. I need to check this formula because I know the derivation, but I don't want to derive. I just want to give you the, this is kind of a short notes I'm providing to you, right? This is a kind of short notes that I'm providing to you. Let me check. T into dou P by dou T, right? Plus T into dou P by dou T at constant volume minus V, I think so, right? Dou P by dou T at constant volume minus P dV, right? Minus P dV. Minus P dV, right? Okay. Okay, correct. So this is basically the equation, right? Now, if I reduce this equation for ideal gas, this equation is for any gas. For any gas. This equation is basically for any gas. This equation is basically for any gas. For ideal gas, this term is going to be 0. This term is going to be 0. So du is equal to Cv dt. Du is equal to Cv dt. This is for ideal gas. Okay. This equation for ideal gas, this equation for any gas. Similarly, if I write dH, so dH is equal to Cp dt, right? Cp dt minus T into dou V by dou T at constant pressure minus V into dP, right? This equation you will get. This equation you will get. This is for any gas. For any gas. This is for any gas, right? So dH value will come how much? Cp dt. This is for ideal gas. लिख लिया. After this, one more equation I would like to write. One more important equation I would like to write. That is Clausius-Clapeyron equation or anything else. Yeah, so Clausius-Clapeyron equation is used to find Clausius-Clapeyron equation used to find the enthalpy change due to phase change. Enthalpy change due to phase change. Clear है? So this value is basically Hg minus Hf. This is only called as latent heat by T saturation is equal to dP by dt saturation region into Vg minus Vf. I think this is the equation. This is basically Clausius-Clapeyron equation. So with the help of this equation, you can find out whatever you want. I think this is only these equations are there, which is important, right? Anything else? No. This is enough, right? Even if you want, you can find out the Joule-Thomson coefficient. The last one is Joule-Thomson coefficient. You can go through with the Joule-Thomson coefficient. Actually, after throttling, what is throttling basically, right? Throttling, please try to understand, it is for throttling process. If you talk about throttling process, then throttling is basically what? Throttling is basically isenthalpic expansion, right? Isenthalpic expansion, and highly irreversible. It is highly irreversible, right? So expansion means what? Expansion means volume will increase, pressure will decrease, right? So basically in throttling process, V2 is going to be greater than V1, right? P2 is going to be less than P1. P2 is going to be less than P1, and enthalpy is going to be constant. S2 is equal to H1, right? But what about temperature, right? Temperature may increase, or decrease, or constant, right? So after throttling, temperature may increase or decrease or become constant. That is depend upon the Joule-Thomson coefficient. So what Joule did actually, Joule have drawn one experimental diagram. That experimental diagram, there are number of this type of curve is there, that is called as inversion curve, and here we have lot of isenthalpic lines, right? Isenthalpic curves, kind of isenthalpic curves, right? This all these are isenthalpic curve. H is equal to constant, and this diagram is basically TP diagram, right? Now, and this curve is called as inversion curve. This curve is called as inversion curve, right? Now, if you look at, suppose here the slope of this isenthalpic curve is positive. Here slope of isenthalpic curve is negative, and at inversion point slope value is 0, right? Now here if you do the expansion of the pressure will decrease. Once pressure will decrease and follow the isenthalpic line, then temperature will also decrease. Means this region is called as, inside the inversion curve is called as cooling region. Cooling region, right? And outside the inversion curve is called as heating region. Heating region. Now, so to identify the exact region, exact place basically, right? Exact region, Joule is defined one term that is called as mu, Joule-Thomson coefficient, that is slope of isenthalpic curve in TP diagram, right? So this value will come, mu is equal to the slope value will come dt by dp, so I can write dou t by dou p at constant enthalpy. This is basically mu value. So if mu value, right, please try to understand, if mu value is positive, then cooling region, right? If mu value is negative, then heating region, if mu value is 0, no temperature change. We can even prove that, right? We can even prove that sir, are applicable for inversion curve? Yes, inversion curve is very, very important, because if you want to design, this process is used in a air conditioner or refrigerator, basically air conditioner or refrigerator. So if you start your inversion, right, if you start inversion from here, means if you start expansion from here, then you will get the maximum cooling effect. To get even these 2 points you can write, Sunny, 2 points you can write here, that for just a minute please. Okay, no issue. Right. Okay. So now I would like to share one, like 2 points are there which you need to remember, right? Only 2 points are there which you need to remember here. The first very, very important point, that this, like sometimes student may think that it is a throttling process, means isenthalpic process. No, you cannot say that it is a isenthalpic process. It is always isenthalpic expansion process. Isenthalpic compression is not even possible, not even feasible. Why it is not feasible? Because compression required work, right? Whenever you want to compress any gas, then it will require work input. And if you supply the work input, then temperature may increase, enthalpy may, because basically we are providing the energy, and enthalpy is nothing but what? The total energy. You are getting my point, right? That is nothing but the total energy only. So this point you need to understand. Throttling means it is isenthalpic expansion. You cannot say, because sometimes student may think that it is basically isenthalpic process. No, it is isenthalpic expansion process. Isenthalpic compression even not feasible. Even if you want, then also it is not possible. That is one thing, right? Now another, so this curve directly you can draw and you can understand. There is no need of derivation. Even we have done all these derivation during our class. So 2 things only you need to remember, that if you want the maximum cooling effect from your refrigerator, right, or from your air conditioner, then expansion must start from the inversion point. Correct? Means in this curve, if you see, if you start your expansion from here, then only you are going to get the maximum cooling effect. Clear this point? Okay. Now the last point I would like to say, the last point of this particular chapter and last point of this particular subject, right? Just a minute, please, sir. Right. So the last point that I want to share here, even we can prove that, please try to understand, we can actually prove that the Joule-Thomson coefficient mu for any ideal gas, it is always 0. It is always going to be 0. So if any ideal gas undergoes throttling process, there is no any changes, right? There will be no any changes. Means if I draw the same diagram, TP diagram, if I draw the same TP diagram for ideal gas, for example, if I draw the same TP diagram, this TP diagram for ideal gas, for example, right? Ideal gas, then it will come something like this. Right? So now you can see that the slope value is 0. Slope value 0 means mu value is always 0. Right? And in this case, you can understand from the diagram also that if you throttle Throttle means what? Pressure is going to decrease. Now, if you decrease the pressure and maintaining the enthalpy constant, then temperature is remain constant. One another way I can prove this, that dH is equal to what for ideal gas, that is CP/dT, right? Now, for throttling process, H value is constant, means dH value is going to be 0. dH value going to be 0 means dt value is going to be 0, means T value is going to be constant, means temperature will not change. Is it done? Anything else you want, right? So the last point is the most important one. The last point is very, very important for you guys. And that the mu value is basically, right, mu value is basically 0 for ideal gas, means if any ideal gas undergoes a throttling process, right, sorry, if any ideal gas undergoes throttling process, then there will be no any change in temperature. So as I earlier told you that this chapter is not that much important as far as GATE exam is concerned, because only derivation part is there, and most of the final outcomes you already know, right? Earlier this chapter were very, very important for ESC conventional type of exam, but fortunately or unfortunately this was removed from ESC syllabus in last change, I think 2018 change. So in 2018 this was removed from the ESC part. So this is all about this chapter. So this is my channel, this is my Telegram channel, Shivam Sir Physics Wala. So thank you very much, sir. You when will come back again for teaching, sir? Whenever you will ask, I will come, don't worry. Whenever you ask, I will come, right? Sir, in isenthalpy process, if the temperature decreases, then the internal energy decreases, right? What increases to make the enthalpy constant, right? Okay. Now, please try to understand H is equal to U plus PV, right? This is a very good question, but actually why you are asking this question, Sunny, because when you are imagining this particular phenomena, then you are taking gas in your mind, right? Then you are considering gas in your mind. That is basically happening. Now I am telling you what is exactly happening in our air conditioner, then you will understand, right? So in air conditioner, you know, there is one throttling valve through which the refrigerant is going to be cooled, right? Please start to understand. It is a adiabatic valve. Now from here, liquid refrigerant is coming. Let's say NH3. Should I take NH3? Right. Okay. So from here, liquid NH3 is coming. Right. NH3. Right. Liquid NH3 is coming. Pressure is very, very high. Let's say P1 and volume is V1. Let's say, just for your example, and temperature is, let's say, T1. Temperature, let's say, T1, and it is a liquid. Right. Clear? No problem, right? No problem. Please start with this. Actual phenomena is going to take place in your refrigerator or air conditioner also. Now, when it is going to be throttle, my dear student friends, right? NH3. So it will be throttle from high pressure to low pressure. Means this here pressure is going to be P2, that is less than P1. Volume is going to increase, right? P2 will be less than P1. Volume is going to be increased. V2 will be greater than V1, right? And temperature will decrease. T2 will be less than T1. And enthalpy is constant. Let's say here enthalpy H1, here enthalpy H1. Right, H1, right? Now, please start to understand, Sunny. Right? Please start to understand here, Sunny, H2 is equal to H1, right? Please start to understand when this liquid NH3 is going to be, throttled, then some part of the NH3 will convert into vapor. Means here we have liquid plus vapor. Here what we have? Liquid plus vapor, and it is a adiabatic phenomena. Now you just assume that for sake of example, just assume that here we have 1 kg of NH3 liquid, 1 kg of NH3. After throttling, half kg liquid is remaining, half kg convert into vapor. Whenever you are converting any liquid into the vapor, then latent heat of vaporization is required. But you did not supply any energy. You did not supply any energy. You are getting my point or not? You are getting my point or not, right? So actually you are not supplying any external energy. So how it get vaporized? How it get vaporized? Because for half, see here 1 kg NH3 is there, half kg NH3 is vaporized, and that actually required energy, but you did not supply any energy. So from where it will take energy? It will take energy from their own internal energy. When it will take energy from their own internal energy, so internal energy will decrease. As the internal energy decrease, temperature will also decrease. This is the phenomena which is exactly taking place in your refrigerator or air conditioning. Right, means liquid refrigerant will convert into vapor refrigerant, and this latent heat of vaporization is going to be taken from their own molecules. So the internal energy of their own molecule is going to decrease, and temperature is also going to decrease. Are you able to understand, Sunny? So I hope Sunny is able to understand. Rarely you will find this explanation in any book. You go and check whatever books are available in the market. Rarely you will find this explanation. Everyone is simply written, any book if you see, everywhere it is written that it is going to be throttled, and due to Joule-Thomson coefficient mu value is positive, that's why temperature is decreased. But what is exactly what is physics behind that? No book is explained actually. You go and check. Okay. Chalo, thank you, bye bye. So this is my channel. Still, if you have any doubt, you can ask. Thank you, bye bye. Okay. Yes, exactly. Okay, thank you, bye bye. So let's meet in some other topic some other day.